Have you started to do your homework? I saw someone working on homework. Yes, right. Homework. Huh?
We have TV report. I don't know which is the best one.
Okay. Mine is not so urgent, not daylight. You can put other for priority first. Okay. Today we will start about material today and next week.
Only like the next homework you like return like I want it I want like send to you by email.
If open, then everyone will be 100 score. Okay, so let's open a new chapter. Circularity of material. And I see someone preview the lecture. Really good. You do every subject, you preview.
Well, only this. I'm too lazy. Yeah.
Oh, that's why you like it. I hope you like it.
Thank you.
No, I hope you like it. Okay, so if I tell you later we'll have surprise quiz, ได้ไหม? But at least be prepared already. Okay, not difficult, okay? Quiz everyone will ตื่นเต้น right when wake up. Okay, so today and this week and next week, 2 chapters we will cover in principle all. Remember last week what you do, right? You do about life cycle of material, and so that time when you learn life cycle, if you have difficulty, try to understand what is the raw material coming from. So now to teach you different material type. So in previous semester, I teach one material per section, but I know you don't like too much material, right? You don't like too much chemistry and physics, so I try to cut. So this semester, I try to merge only two chapter, okay, about material. But you still need to understand what is metal, ceramic, and plastic polymer. Okay, so we will walk through all this material. And after these 2 chapters, you're supposed to be able to identify every material and how they come from. And then you are able to identify how to handle when this material degraded or when this material become waste. Okay, this is my purpose. You need to understand material property. Okay, so let's try. We need to touch a bit about material science. So one general question. So just now I say many different material type, right? So you see here, we have plastic, aluminum, and metal, and paper, and glass. So you see which material we can continue recycle without degradation? Aluminium, that classify as metal, perfect. Okay, so you need to have this sense. Metal, you can try to keep loop 1, 2, 3. The property keep the same. That's we say they are not degrade. And then, which one? Which one followed by which one? You see here. Which one is the worst one? Plastic. Oh, do you know why? What's the fundamental difference between metal and plastic? What makes them different? Why metal can keep cycle many loop, but plastic only 1 or 2 times it degrades. So what is the fundamental difference between these all material type? Have you learned something from high school about chemistry? What's different between this material? Structure? Okay, can you break down more? Before structure, what's that? How they form the structure? Okay, so atom and how the atom become a structure. I need something between here. Okay, crystallinity, that is a structure. But I mean, you have individual atom, right? How you bring the atom become structure? ภาษาอังกฤษ So you have many atoms, right? ใช่ So what's that? Yeah, what? Yes, correct. And how they connect? Bonding, perfect. That's the word. So what's different? All them are bonding different. Metal, what kind of metal? What kind of bond we have metal? Hey, you learned this one, right? No. Huh? Not ionic. Inside the metal, what kind of bonding? Okay, everything have electron. Hey, by the way, everything have electron, okay? Everything. Hey, someone give me the answer. What kind of bonding in the metal? Not ionic. What kind of bonding else have you heard? Covalent, right? Okay, now you talk to me covalent, ionic. The last one. Hydrogen. So hydrogen bonding is a secondary bonding, it's a weak bonding. The primary bonding with 3. There's another one. Ionic, covalent. Last one. อะไร James Bond. Last one. Anyone know? Last one. This one is metal. Metal is, yeah, metallic bond. Perfect. Which one here have ionic bond? Which one? Which one? Aluminium is metal, right? Which one here have ionic bond? So now metal is aluminium, right? Aluminium have metallic bond. Just now you tell me ionic bond. Ionic bond. Which one have ionic bond? Huh? อะไร Which one? No. All the metal is metallic bond. So which material have ionic bond? Material. Yeah. So another one. What is another one? And by the way, okay, we had 3 group material, right? Metal. Yeah. Thank you. Ceramic and polymer. Okay, so among these 3, which one is ionic? Ceramic. Okay, so which one is ceramic? Glass. Perfect. Huh? Chai, I asked ionic.
I haven't got grade 4 in chemistry.
เอาจริงอ่ะ How much score you get?
2.5.
Oh, I feel sorry. Okay. And which one? So plastic, what kind of bonding? Correct แล้ว Finally. Huh? Review. Okay, I will help you. Reboot. Okay, I will reboot. Okay, so as I say, every material they have electron. But why metal act like a metal? Why they become so conductive, right? However, plastic they are non-conductive. Oh, they are electron. So what's make different is bonding type. Okay, and also why we say the plastic why it degrades so fast? Because the covalent bonding is a weak bonding. So once you do 1 ton, 2 ton, you destroy. Okay, also remember, bonding type is important when we talk about material property. Wait, good, so quiet. I like it. Okay. Material. Okay, so what's the material science? Actually, everything. You learn everything surrounding you. When you look at everything here is composed by material. Huh? Oh, okay. So actually, whenever you see the new technology coming, right, it's always coming a new material. So they announce, we figure out some breakthrough. And it's always involve new material property. So actually, material subject is not something new. It's combination what you learn from chemistry, what you learn from physics, but in more applications. Okay, so later in the future when you work, for sure you work about material. Depend which kind of industry you go, but it involves different material type. อันนี้ง่วงนอนใช่ไหมทำไม why smile เมื่อวันไปเตะใช่ไหม turtle turtle ฮะ turtle อะไรอ่ะ ไม่เข้าใจอ่ะ the straw bar and he's เต่าอ่ะเต่าใช่ไหมเต่า Master 乌龟 Okay, so material science actually is important. Our human history also separate by material. So do you know what is the first material we use in our human history? Stone. Stone. So how we call that age? We. เพราะว่า you review ใช่ไหม Have you seen the cartoon? This one? It's too old, right? It's too old for you. It's not your generation. So first one is a stone, right? Stone age. And then what is the second one? Brown. So actually it's part of copper, but it's the alloy. You know what mean alloy, right? You mix more than two metal become alloy. And then from Bronze Age, you go to iron. Okay. Then silicon. Which one you think? Which generation you think we are living today? Polymer? Really? Silicon. Why polymer? Yeah, because especially your generation, because you have so many electronic products, right? Why they are possible? Because we figure out the silicon. So actually, you are in this silicon age. The new material we use a lot. Okay, silicon age. So one thing I will teach you about material selection process. This one. Because last year, my final exam is coming from this one. So I haven't made it yet, but you need to understand what's being called material selection process. That's a 3-step. We call process, structure, and property. So what's mean here? Which one you think, these 3 steps, which one you think we start first? When you are the product design, you are thinking what material to use, which one? You start from process? You start from structure? Or you start from property? Which one? Property, perfect. So you start from property. So that is stage 1. And then you follow back structure, then process. Okay, for example, I use silicon for example. Okay. Do you still remember what is a good grade silicon and then the normal grade? Okay. For example, for solar cell, what do you use? Solar cell and transistor. What's different from the silicon? Huh? Okay, what's different the silicon material you use for solar panel compared silicon you use for transistor? Do you still remember 2 crystal structure? Which one need a high grade? Transistor, perfect. We need a single crystal. Sorry, another way around. I need to start from, start from property, right? First, I need to teach you what property you want. For transistor, you want fast switch, right? The property, you need higher conductivity. So that's a property. So higher conductivity more than, if I do this one, you understand? Can I write here? Because we want to teach you about selection process. So for property, okay, for the silicon chip, transistor, and solar cell. Which one we want high conductivity? Which one? We need higher conductivity. Chip, right? Okay. Okay, this one is moderate. Then, solar silicon chip, we need higher conductivity. That is called property, right? What you want. So next step, what kind of structure can make high conductivity? So that's step 2. Do you remember what structure? That's a midterm exam, but I think I will bring back to test you again. Do you remember what structure? Mono crystalline. There's 2. I will let you guess. One is slow cooling. Another one fast cooling. You think which one is slow cooling, which one is fast? Yeah, correct. Why you know silicon need to be slow? What means slow? So for the material science, later you will hear about so many annealing, we call thermal treatment, because in the nature, these always have a defect in our material. So in order to fix the defect, you need to having some energy. And when you try to cooling slow, it means the atom have enough time to go to the right position. So they become single crystalline. But if you cooling too fast, the atom don't have time to go to the right position. You already fix and freezing them in the bad position. That's why you don't get a good crystal structure. Okay, so this one we call material selection process. Start from backside to what you want, and then you decide what kind of structure can get this property, and then you go to see how to get that structure by the process. So this one we call material selection process. You need to remember these three. Okay. This also, when you do the final group project, if you design some new material, you also need to judge by here. You judge first what kind of property you want. They can help you to decide what material you need to pick up for this purpose. Okay, by the property first. This will be the exam. But easy, right? Understand? Okay, good. So, which metal you think we are using a lot in our activity of a human? Iron. Because you preview, right? Okay, so here show you what is scarcity. So it means the material facing shortage. You remember we are talking about circularity, right? And we're talking about circularity, the first step, material extraction, right? Last week, material extraction, the first step. And here, elementary table, they are show us what is available material in nature. And here, further show, because we use a lot, so which material actually we have problem now. We don't have too much in nature. So, for example, what you know? This one, happening. This one, using in the transistor chip. This one also, right? Transistor, right? The same. Here, transistor. And this one, using some of the solar panel have this one. So if you notice, all of the elements we having a challenge, they are all related to our semiconductor product. These three main reasons why the material will become scarcity. The first reason, the material is depletion. Second, technical reason. What is technical reason? For example, certain product increase. Which product you can think nowadays? Which product? Gold? No, I mean product. Gold. Which product in your I think this year, last year, which product never happened before and now so many increase usage every place? All the AI related product. Right? So all the AI related, you need a CPU, you need a PCB board. So even 2 years ago, we don't have so much consumption demand. But only these 2 years, because of ChatGPT, every AI machine learning model coming, some material, they are facing an issue because this period demanding a lot. So that's the second reason why some material facing scarcity. Third one, political reason. I guess this one easy to understand, right? What kind of situation you see is due to the political situation. Do you see why we facing the oil, right? Because the war, right? And Iran control, right? So right now, it look like only impact oil. But you know some of the rare earth material, they are only in a certain country. So they also, For example? Water. No, I mean the rare earth material. Oh, you know, right? The rare earth material. So when Trump argued with China, China stopped export the rare earth. You know which one is rare earth material, right? Which one? Which one in the elementary table is rare earth material? Something here, right? Something here. You don't use often, right? Okay. And also something in the middle part. We call rare earth, and majority is in the China. So when there's a war with Trump, I cannot buy because I used to buy the chemical from China, and then the vendors say they are not allowed to export because they are political argument, right? So they want to stop to export. And perhaps you don't feel the consequence because some rare earths they're using in also critical parts in the AI chip. So that's why Trump a bit worried. He's also trying to dig in the new source to find this rare earth material. Okay, so 3 reasons why material was facing scarcity. It's using out depletion. Second, technical reason because this period, we use a lot of certain product. Third one, political reason. Okay. Second, why we talk about here, 2 page here is a justification why we need to worry about metal circularity. First reason, scarcity is almost run out. Second reason, pollution due to mining. Okay. Do you think what kind of pollution we will have when you do the mining process? A lot of pollution. Yeah, for example, what pollution? Air pollution. Yes. So you have so much byproduct, right? The byproduct, you need a chemical put in. You also have the byproduct gas emit to the pipe. That's called pollution for mining. So that's the reason why we need to try to do recycle of metal. I try to tell you the reason why we need to do recycle. Okay, first, because we don't have so much now. Second, because your mining process is so polluted. That's the reason why we do metal recycle. You remember 2 reasons now? Okay. Not because we almost run out, also because pollution. But then you will ask me, so why recycle will be less pollution, right? Oh, why? Yes, because if you take the recycled one, you already have higher purity. You don't need to add any chemical to increase the purity. So actually, energy consumption less, also the byproduct is less. Really preview, eh? Good. So, as we say, the number 1 of metal in today, our generation, the most we use is iron. And what is the second one? Do you see? Number 1 is iron. Number 2 is aluminium. Okay, so you just need to remember these 2 because we use a lot for all our daily industry. Okay, you just remember these 2. The rest, Oh, the rest like nickel, we will teach you a bit cobalt in the EV car battery. That is today's situation. Okay. As we say, all the property different is due to the bonding. Okay, I know all of you don't like chemistry, so I already cut it to small. So this, do you know what this model we call? Model. Bohr model. 金土的. Okay, Bohr model, B-O-H-R, okay? Bohr model. So Bohr model is the orbital model with a nuclear in the middle, right? And you see so many electrons surrounding the nuclear. Which one is the important electron in this model we need to care? Valence. Okay, where is the valence electron? The most outside one, right? Okay, perfect. So all the valence electron in the outside shell will decide all material property. Just now I told you binding, right? And then binding actually happens from valence electron. And all the material property is decided by this valence electron. For example, what's mean chemical property in the material science? For example, chemical property. What kind of chemistry you do? Have you run any chemistry lab? At any reaction you do? In high school? Oh, what reaction you do? Oh, I want to teach you what's mean good reactive, what's mean non-reactive. What kind of reaction you do? Huh? Have you do any reaction? Yeah, what kind of have you tried to do the nylon? Have you done the nylon polymer in high school? Oxygen? How you do? Oh, so you have electroplate, right? Oh. Okay, good. So what's mean reactive? What's mean non-reactive? It's ready to provide the binding, right? So it means your valence electron ready to form bonding with another atom. So for chemical property, it's about reactive. Reactivity of valence electron. So if your valence electron ready to form bonding to another one, we say, this material is reactive. Okay, so that's what's chemical property. How about electrical property? What's relation with valence electron? Oh, electrical is mean conductivity, right? But what's mean good conductivity? What's mean bad conductivity? And then, which one? Which electron? There's so many electrons, right? So, good conductivity is mean the valence electron easy to move. Okay? So, the electrical property is the motion of valence electron. So if valence electron easy to flow, this one is mean good conductivity. Huh? I'm trying to explain why all these material properties are related to valence electron. And last one, thermal and optical. Do you know what means thermal? Heat. Oh, and why we generate heat? Think back to crystal. Okay. vibrations. And that is the lattice vibration interaction with the valence electron. So the thermal is due to the interaction of valence electron with the lattice vibration. Lattice is the material lattice. You know what's different from lattice, electron, and atom, right? Lattice. And optical. So what is optical property? What kind of optical property you know? What's the mean optical property? When you look around, which one is optical property? The window can passing through the light, so what kind of property? Huh? Transparent, so it means the light can transmit, right? And how about mirror? When you look at the mirror, what kind of optical property? Reflection, perfect. So actually we have reflection, transmission, and refraction. And that's why you know what means refraction, right? When you see the strobe are bending, that is a refraction, the bending of the light. Okay? So all this property is also related to the interaction of the wave. But actually, light is a wave, right? But actually, wave also composed by the electron particle. So all here is called material property. I think last two is easy for you, right? You know all chemistry part. Which one heavier? Electron, proton, neutron. Which one heavier? Proton and neutron, right? And electron actually lighter. How much lighter? 1,000 times, right? It's around 1,000 times. Okay. So all here you learn, you remember, right? The chemistry you learn. Okay. So now let's talk about metal. So metal using metallic bond, okay? Metal using metallic bond. And metallic bond, the definition is electron act like C, okay? So they are not don't having a fixed position now. So you see this electron, it could be belong to this, also could be belong to this, but we don't care. As long as you give enough potential, electron will flow. So that's why metal have good conductivity. A bit hot, right? Tonight. You feel hot? I mean the airflow, my dear. Okay, since most of you remember what's mean crystal structure. So first we have atom, right? And then atom and anton binding due to valence electron. So when you bind more atoms, you form a crystal. Okay? So atom binding crystal. And you remember what's mean single crystal, what's mean amorphous. So if you look at these two pictures, upper, lower, which one is crystalline? Which one is non-crystalline? It's easy, right? Oh, so upper one here is crystalline. Lower one is non-crystalline. Here, the example I want to show you is SiO2. SiO2 actually just a glass, right? Glass material. So have you seen crystalline glass? What does it mean crystalline glass? Oh. crystalline glass. Have you heard about quartz? Quartz. So quartz is belong to crystalline glass. Actually, one product I like, do I put here? Have you heard about Swarovski? Do you know that this brand, Swarovski? Oh, which country brand? Russia? No. Anyone, Swarovski? German? No. Huh? Switzerland? No. Closer now. It's the Austria. So not Australia, Austria. So Swarovski is belong to their. So Swarovski actually just a glass, but why you ready to pay so expensive? Because they made the glass become crystalline structure. So each glass looks so shiny and so much facet. So but actually it's just glass. Swarovski crystal, we call crystal, right? So the crystalline SiO2, the product you saw is Swarovski crystal. Okay? And then how about non-crystalline? What kind of product you see? This one? What kind of product? You know, non-crystalline or we call amorphous. What product? Oi, window. The glass. Okay, normal window, normal glass is amorphous. You don't need a good crystalline structure. Okay. So crystalline material definition is mean they are order arrangement in the 3D array. So you can see crystalline in most of the metal. We can have a crystalline structure because most of metal is single atom, right? Copper is copper, aluminum is aluminum. So it's easy to have crystalline structure like silicon. And ceramic also can, like SiO2 here. This is ceramic, and only a few polymer we can make it crystalline, but it's hard because polymer is acting like long chain and irregular structure. And non-crystalline is mean opposite, right? So you see, non-crystalline we can get is fast cooling, and this one slow cooling. This is a question just now I asked you, right? Slow cooling and fast cooling here. Slow cooling, you can get crystalline structure. Fast cooling, you get amorphous structure. Okay. So remember material science. We don't use non-crystalline. We use which word? Amorphous. Okay. Material science, we use amorphous. To show you Swarovski. SW Swarovski. Oh, I think you can search Swarovski crystal. Okay, that is glass actually. Okay. So here it's just one material page for metal. So metal normally, they can be densely packed. And why? Because normally metal, I say right, they are single element, iron, and copper, just copper. So most of the time, you are single element. So the benefit single element because it's the same, no different. When you go to all the direction, they are facing the same atoms, so they can pack very dense. You know what I mean packing, right? Packing. Think about this, the atom is a ball. So I say when we talk about material science, we are not talking about only one atom. You talk about many atoms that pack together. Okay, this one we call packing. So you see, actually for material science, we even need to calculate how is the packing density. For example, this one, compare this one. Do you see what's different? Left and right. Different, right? Even there are 4 atoms, right? Which one have better packing density? the right side have less hole in between. When we teach this one, I will ask you to do the real calculation. Okay, this side is right? Right, you are right. So the right side and left side. The right side have higher packing density because the space less. But if you just think about ping pong ball. You can try to pack in by ping pong ball. And this one in the middle, you have bigger space. Okay, for nature, which one we prefer? Higher or lower? Nature tend to have lower. Yes. So nature tend to have the right side. That's a nature tendency. Nature always try to find a minimum energy. Okay, so nature prefer the right side. And metallic bonding is non-directional. It's easy to understand because it's just single element, right? So even you go to right, go to left, go to up, go to down, it's the same. So this non-directional. Because ceramic is direction. Okay, because you have ionic exchange, right? So we will teach you when we talk about ceramic. Okay, so actually because normally here we will teach you crystal structure, but I guess it's difficult for you, so I just show you, but it's not included in the exam. So actually this one called crystal structure. So today we learn iron. Iron crystal look like this one. Aluminium crystal look like this one. So you see here, iron, you see packing 1, 2, 3, 4. This structure is the one I draw. Disappear now. The one just now I asked you, right? This is this structure. This is the iron one. Okay. So for you, you don't need to go detail now. I skip this one. So you just remember this what I call crystal structure. So when I say single crystal, next time in your mindset, you can think about is the atom going through 3D dimensions. This one is called crystal. Okay, but I skip the structure part. Okay, so what's the property for metal? What property you know? Property, what's it mean property? Okay, malleable. So it means you can extend it, right? What kind of property for metal when you think about metal? Conductivity, yes, perfect. That's the most important one, right? So you see here, they are solid in room temperature. They are shiny if you can polish them. So it means the interaction with the light, they can reflect the light. And then most important, they are conduct to heat or electron. Okay, so the fourth one, the malleable, it means they can bend easier. That's why you can make your car door, to make the car, right? And also you can stretch. Okay, they are ductile. All this is a property. Okay, what's mean alloy? Won't know. Everyone's sleepy. What's mean alloy? Okay, more than one, right? You're mixing. So, for example, have you heard about steel? Steel. You know what means steel, right? We build a house, build a building using the steel bar, right? So, do we have steel, this material in nature? No, right? Oh, why? So what is steel? If we don't have it in nature, how can we make steel? To make what and what? Iron plus? Perfect. So steel is alloy. So alloy we don't have in nature. Okay? So that's the part. Compare iron and steel. Iron is we can get from nature, but steel is we make it. Okay, I'll tell the difference. But why? Why we not satisfied just using iron directly. Why we need to mix something in iron to make new material out? Huh? Sorry? And something else? Yeah, iron actually is quite soft. Pure iron is quite soft. Also quite easy to roasted, right? So you want to make the material become corrosion resistance. So we have many reasons why we do alloy. So here, why we create steel, especially stainless steel. You know stainless steel, right? Do you know why we put them? We can make them become stainless steel. One material inside. Huh? What material in stainless steel? For sure you have iron, for sure you have carbon, right? But something else, we make stainless steel. Chromium. Chromium, more than 11%. Okay, so stainless steel, we add another metal inside. It's called stainless steel. Okay. Can you tell me which one is alloy? Which one? Which one is alloy? You see here, which one? Steel, perfect. Which one you saw is alloy? Brass, wrong, perfect, it's alloy. Solder, have you played solder material before? Yes, someone do soldering, right? Oh, why soldering while mixing? Because once you're mixing, you can lower melting temperature, so you can easier melt metal. That's why you can operate by yourself. Normally the metal you need to melt in high temperature, but once you mix, you can lower the melting temperature. Do you want a break? Yes. Yeah, because I saw the next slide become difficult. Let's have a break. Okay, 15 minutes.